The next question says find the arc length of the graph of the function over the interval 0, 9. So remember the arc length is the integral from a to b of the square root of 1 plus the derivative of y squared dx. So my derivative is going to be 3 half x. If I subtract 1, I get to the 1 half. And the derivative of 3 is 0. So this is just going to be 3x to the 1 half. So I'm going from 0 to 9 of 1 plus 3x to the 1 half squared. So using a calculator, my arc length ends up being 54.929. The next question asks me to find the region bounded by the graph of y equals 2 square root of x, y equals 0, and x equals to 3. So the next problem is that the region bounded by the graph of y equals 2 square root of x, y equals 0, and x equals to 3. Find the surface area. So the formula for the surface area is the integral is 2 pi integral from a to b of y square root of 1 plus y prime squared dx. And remember that y is the distance between the axis of rotation and the graph. So if we graph, there's the square root of 2 square root of x, y equals to 0, and x equals to 3. So we want to find the surface area of this figure. So as we rotate it, we end up with a figure, a cone. So we're trying to find the surface area of the cone. So what we're going to do is we're going to find my derivative. So I get 2 times 1 half x to the negative 1 half, or just x to the negative 1 half. Then we need to find y. So y is the distance from the axis of rotation to your graph. So y is going to be 2 square root of x. So my surface area is going to go from 0 to 3 of 2 square root of x times the square root of 1 plus x to the negative 1 half squared. And I end up with 56 over 3 pi. The next question says find the work done in stretching the spring from its natural length of 10 inches to its length of 15 inches if the force of 4 pounds is needed to stretch it 1 inch from its natural position now. So its natural position is at 10 inch. So for us, that's considered 0. So it's stretching, it uses 4 pounds, so the force of 4 pounds to stretch it 1 inch. So that is what we're going to use to find K. Remember, the force of a string is K, the constant, depending on the string, times X. So since X is 1, K is 4. So the force of this spring would be 4K. So now we want to find the work done by stretching the spring from its natural length of 10 inches to 15 inches. So I'm going from 10 to 15. So I'm stretching it from 0 to 5. So my work done is going to go from 0 to 5 of 4x dx. So my work done would be 50 pounds inches. The next question says a chain 10 feet long weighs 5 pounds per foot and is hung from a platform 20 feet above the ground. How much work is required to raise the entire chain to the 20-foot level? Okay, so we have a platform that is 20 feet above the ground, and we have a chain, but it's only up to 10, because it's only 10 feet long, and it weighs 5 pounds per foot. So we need to find the force of the change, so it's the weight. So originally, it weighed 5 times 10, which is 50 pounds. So here, when all the chain is hanging out, it weighs 50 pounds. But then as we pull it up, it's losing 5 pounds per foot. So my work done, and here's where the trick is. Since you're pulling it up 20, you would think, oh, I'm going from 0 to 20, but you didn't really pull it up 20 feet because the chain is only 10 feet long. So you're not going to pull it up another 10 when it's not there. So you're actually just going from 0 to 10. So my work ends up being 250 pounds